In my previous two videos, I've shown you how to convert a profile into a surface and how to convert a surface into a mesh, and explaining the difference between 2D and 3D triangulation and some use cases for everything. And then the next video I've shown you how to use extrusion together with drawing on objects to combine and create these objects, low poly object, and so on. Now I'm going to show you one other method, which is converting an object's wireframe into an actual mesh. And this is a use case that I've seen a lot coming up. I'll show a very basic example cylinder that may not be so practical, but it has real use case. So let's say, for example, you have this wireframe that we see over here, and you want this to be printed something like this, like a net, instead of printing entire mesh. One of the most basic ways to do something like this that very few people know is that you can use chamfer and fillet. SelfKit has a setting in chamfer and fillet, which is fill polygon. You can select, if you deselect fill polygon, then you end up staying just with the mesh. And just a side note that this will always intensity is based on until it starts self-intersecting. So if you take a mesh that has a lot of details, for example, the default cylinder as a sphere, this would be only 0.4 or something like that. But nevertheless, it could be used quite efficiently for this. And if you do something like this, you can see this has flat rectangles. I'll show you in a minute the difference, but still you will have to add thickness to this. And let's say we add a -5, should be fine. And now you have a mesh that looks like this. Just turn the wireframe into a mesh. Okay, now let's say, as I said, I'll show you the difference between, you can also use fillet. And if you do fillet, the same idea, you turn off the fill polygons, but now you have more flexibility for the amount of details, and the default would be 2 is the minimum, so it starts creating something like this, and then you start creating more. For a basic cylinder, this is not a big difference, but in some shapes, this makes a big difference how this could be done. And the same, you have to add thickness and so on. Okay, so now let me add another example to show you more advanced use cases, because in this example you're limited to what this tool gives you and you don't have a lot of flexibility how the wireframe should look like. But what if you want to have complete flexibility? And this is where I'm going to show you the follow path approach. So first what I'm going to do is I'm going to ring select this entire thing. I'm going to copy it, and now I'm going to go to this again, and I'm loop select the bottom. The reason I didn't do it together, I'll show you soon, is because I need them to be two separate profiles, because otherwise this may create unnecessary difficulties, and I'll show them in a minute. So now I'll go to copy offset, and I'll move them up, let's say by 10, and I'll make 10 copies, something like this, and this gives me this mesh. Now, one thing is interesting with SelfKit, that they keep it, everything is kept selected as you use these type of tools. So it's very easy to merge them together and you have no problem. So now you have two separate files. Okay, what I'll do now is I'm going to, actually I need to scale this a little bit down, because if they only touch over here and touch over here, this may create an issue with Boolean that we're going to use later. So I'm going to scale this down to, let's say 95. Okay, so we make this a little shorter. I could have scaled probably later just the objects, but nevertheless, it's just over precaution. But anyways, let's go to 3D sketch, and I'm going to create a simple circle, and obviously it could be different shapes. Let's actually, in fact, let's make a different shape. Let's make it, let's say just 8 edges. Okay, so it's not perfectly circular, and I'm going to scale this. Could have used the size in the drawing directly, but yeah, why not do it over here? And now I have this object over here. Okay, so once I have an object selected, what I want to follow, that's how follow path's using. I can select then the second object, the second profile that I wanted to follow, and I go now to follow path, and look what happened. So we got this shape over here. So again, these are all selected, so I'm just going to merge them. If they don't self-intersect nothing, there's no problem merging them. It wouldn't create any issue. Now I'm selecting again the profile that I want to follow, and I'm selecting all of my vertical lines, and I use again follow path, and now we get this shape. So I did it a little bit too much out. Should have scaled them less. Okay, but nevertheless, it's not perfect. Just for this example, I'm going to merge them again. So I have now two separate objects. once I have these two separate objects, I'm going to go to stitch and scoop, and I'm going to combine them. And in this case, we got our mesh. So I can isolate this, do something like this, and I get this mesh by itself. Or, and that is properly cut. If you can see over here, stitch and scoop did a good job. It's cut properly. This is done nicely. Or I can use it together with the original object and do either stitch and scoop union to combine them. That could be an option if you want to combine them, make an object like this. Or more practically, you want to remove this and create an object with these type of lines. And you get an object like this with these designs, nice tile designs, which could be quite nice. And this, because I created only 8 edges on this, created like this sharp corners over here, which makes it look nice. And obviously you can do a lot of other differences with that. That's basically it. That's how you convert a wireframe into a mesh. And you can do the same with any drawing that you have. But one last thing that I want to show you is why I had to do them separately. So let's delete this object. And let's go back to the original object. So I have this object and I have this object, these two objects. So let's say I'm going to merge them together. Okay, so merging is actually an interesting process. I want to see actually if Selfcat made the cuts. It should have made the cuts. Yes, you see Selfcat is cutting them automatically. It detects, it added the vertices with all of these intersections. So this is done a quite good job because now you can start cutting away pieces. So this is actually done quite nicely. But the problem here would be if you start following this and start following this shape, you'll end up having separate objects for each of them. So let me show you. First of all, it'll take much longer. I mean, it's just a few seconds longer, maybe. It's not a big deal, or a few milliseconds longer in this case. But what's happening is that you end up having so many different shapes. Look, it takes even time to render these images of them. You end up having like what? 1,000 shapes. I don't know how many shapes you start having. Each of these are separate shapes. And the problem is that each of these intersections may potentially create some gaps or some imperfection. In my previous example, it was also not 100% perfect. To make it 100% perfect, actually, Magic Fix is something that's probably the best idea to make it perfect, or before that, scale it and position it to make it perfect. But in this case, you end up having so many different things, because what's happening is, to show it in a different example, what's happening is that, and just delete them all, look how many objects we have over here. I guess it did not delete all of them. Yeah, I did. Okay. So just to show you as a simple example what's happening, so I'm going to draw a simple sketch, and I'm going to draw something like this, and then escape to cancel it and draw something like this. Okay. Now, if I fill this, and now let's draw it as a separate profile, something like this, and then as a separate profile, something like this. Okay. So now let's see the difference. If I'm going to use fill this and then track this, okay, and I use follow path, we got this shape. Okay, now let's take again this circular shape and select this and go follow path. Okay, so we end up having two pieces and they are completely something like this, and then I can just do union, select these two pieces and combine them together, and they are without any problem, and there's a single shape. Okay, if I would go now and select the same profile, let's say this, and then select this profile and do follow path, we end up having 4 objects. Okay, and in this particular case actually it's not a big difference because they look okay, they intersect each other, and union shouldn't be a difference. But still you can see I end up having 4 objects over here. And in some use cases, especially if you do corners, like if you would do, for example, a circle, let me show you a real use case where this could be an actual issue. Okay, so actual use case. So I'm going to draw, actually let's take a cube, not this, let's take a basic cube, and I'm going to add some details to this. I'm going to go to edit details, and I'm going to add a vertex. I'm going to add something here in the center, make something like this. Okay, now I'm going to copy, convert this to edges. Oh, need to go to faces, select these faces, all faces, and convert them to edges. And I'm going to copy these edges. So I have this profile done. Okay. So now what will happen is if I select, I can get rid of this cube already. I just wanted to get this shape. If I take this and I follow this as it is, follow path, you'll see here at the corners, we end up having these issues. Here you see we have a gap here. Okay, so what if, let's delete this. What if I select this and I split off these pieces? Let's split this off, make it a separate profile. And I'm going to fill now this plus this, follow path, fill this. Okay, and let's take a look at this. Look how sharp this is, beautifully connected. And now if I go separately and I select this plus then afterwards this, and I do follow path, and you see we got these all connected. Now I'll select this, and now I'll go stitch and scoop, union. Now you see we got a beautiful shape. This simple X we've seen before doesn't really make a difference, but in this particular case, it made a big difference. So now you have a nice clean connection. So yeah, so that's basically it. I hope this was helpful, and let me know if you want me to show something else. Bye.